everyone, and welcome to Kwame Transformer Day, the latest in our ongoing webinar series. Firstly, I'd like to introduce myself to you all. I'm Victoria Pope, and I'm the new Head of Content for Kwame at Hive Group. I'm looking forward to getting to know everyone in the coming weeks and months, and to hopefully meeting in person in the not too distant future. Today, we'll welcome speakers from Power Technology Research, Block Transformatoren, Cargill and Eaton, covering topics including transformer market and component developments, innovation and challenges in the utility transformer space, and the influence of new semiconductor technologies on the materials of inductive components. I hope you enjoy our informative sessions, and please do feel free to ask questions of the speakers throughout. Before I introduce our first speaker, I'd quickly like to go through some general housekeeping rules for today's webinar. The webinar will last for around 60 minutes, with 10 to 15 minutes for Q&A at the end of the presentation. You should all see a panel on the right-hand side of your screen with various tabs. If you have a question that you would like our speakers to answer, then please use the question function in the panel throughout the session, and we will get to them at the end of the presentation. Any questions left unanswered will be responded to by the speaker and published alongside the webinar recording on the Kwame website later this week. The chat function will also remain open throughout the session, so please feel free to use that for additional comments or to shout if you have any technical issues, and a member of the team will be able to help. Without further ado, I would now like to introduce our first speaker for today, who will be giving you an early insight into our upcoming Transformer Market and Component Development White Paper. It's my great pleasure to introduce Saqib Saeed, the Director of Research and Consulting at Power Technology Research. With that, I'd like to hand over to Saqib.
All right, great. Thank you, Victoria. Thank you for the introduction. Welcome you all to the webinar today. The topic is basically the Transformers Global Market Overview, which, as Victoria said, is kind of an overview of the white paper that we're publishing in collaboration with Kwame next week. This is going to have some, let's say, extracts of data and information from that white paper. The session is designed for a complete hour. We'll have a Q&A session towards the end for 15-20 minutes, so feel free to ask your questions. And if we are unable to answer any questions, we'll make sure that we answer those questions even after the webinar as well. Very quickly, to walk you through the agenda today, I'll start with a brief introduction of PTR as to who we are and what exactly do we do, which topics do we cover in terms of the research, and then we'll jump right into the topic of power and distribution transformers. Primarily, the idea is to understand what happened in 2020, market size on a global level, and then also looking into some of the regional segmentations, which were the growth areas if we look at different regions around the world, and then some key markets broken out from those regions as well. And then finally, we'll discuss some of the key market trends, what were the growth drivers, and how does the outlook look like for transformers, distribution and power transformers. It is very important to sort of segment out the impact of COVID-19, not only on the transformer sector, but also on overall T&D, which is transmission and distribution sector, which markets were impacted more than the others. So that's what we'll discuss in section 3. And then basically section 4 would be primarily on the upcoming growth drivers. This is where we'll discuss a very important topic of EV charging infrastructure. How is it supposed to impact the market of transformers and overall power grid infrastructure? Renewables is something which is definitely going to impact moving forward the transformers and power grid market. And finally, digitalization. So these would be the 3 topics within key market growth drivers that we'll discuss. And as I discussed earlier, we'll have 10 to 15 minutes of Q&A session towards the end of the discussion. To start off with the company introduction, PTR is a market research company really focusing on 2 key areas: power grid and anything which is in and around the power grid. These are the topics that we cover on global level. As you see, starting from the legacy grid equipment, transformers, switchgear, flexible AC transmission systems, HVDC, synchronous condensers. So all of legacy grid equipment is something that we have been covering for 5 years. And then areas like substation automation, new areas like DC power grids. Within that, shore power or shore to ship power is a new topic that we've started covering. Smart meters, power factor correction, and grid communication. And towards the right-hand side, this is where, let's say, movement is happening as far as the power grid is concerned. EV charging infrastructure is a main topic which definitely interacts with power grid. So since we are covering EV charging infrastructure separately from grid, it lets us sort of understand the interconnection between the two as well. Storage value chain is a very important piece of the puzzle. A combination of all three is something that we study as well. There is a lot of discussion around the electrification of passenger vehicles, but beyond passenger vehicles, there is electrification happening in commercial and off-highway vehicles. So that's why we have a dedicated topic, which once again, research from this topic gets plugged into many different topics as well. And then finally, two topics on traction motors, and motors would be on the rotating machines that we cover separately from power grid area. What exactly do we cover in these topics? A lot of the research that we conduct is bespoke and custom. This is where basically we look at what the demand is from our customer side. It varies from market sizing, comparative analysis, market accessibility. So oftentimes we are providing kind of a combination of all three of them, or maybe a deep dive into one of these areas. Within market sizing, of course, understanding what has happened in the past. If you're comparing different technologies against each other, so looking at historical data is very crucial, and then understanding the outlook as well within market sizing. That's where, let's say, a key factor that we look into competition between different technologies and different application areas, because growth is, of course, not supposed to, let's say, happen in all different applications. We sort of understand the combination and then comparison of different technologies and applications. Comparative analysis is where we try to understand who are the winners of the market. So in terms of market shares, SWOT analysis, benchmarking, that's where we try to understand the comparative landscape of all these topics that you saw previously. Market accessibility is where we try to understand how the business is basically done. And since most of our research is conducted on country level, so that's why we try to understand in all those areas how exactly business is being done in these areas. So starting from business practices, what kind of regulatory framework that exists, any key product and market trends, and sales channel analysis. And once again, oftentimes we have, let's say, package reports as well, where we would, let's say, combine all of these topics together to have a complete package, or in some cases where the demand is, maybe for a certain topic, we would do a deep dive into market sizing only, because that's what the demand is from the customer side. Just to give you, let's say, a deep dive into how this research is conducted, this would be an example of how transformers research is conducted at PTR. As you see, we're covering different applications where the growth is supposed to happen for power and distribution transformers. So looking into transmission sector, distribution sector, generation, and industry. And then, as I discussed earlier, having sort of a slicing of the data to understand which technology is supposed to take over the market share from the other one. That's where we do this kind of slice and dice of the data in terms of the insulation medium, voltage, in terms of the applications, and then finally looking at the install base once again to understand the historical trends, and then new additions which are supposed to happen in the coming years. And we'll see, let's say, some extracts of this research, which is going to go into the white paper as well, and then also in today's presentation. All right, with this, I'll jump right into the topic. Idea is to understand what happened in 2020. Of course, COVID was a big topic. How did it impact the transformers market overall, and then in general T&D market as well? This is where we'll start with a brief overview of the market size, looking into the global market overview, and then moving into the regional segmentation and some of the key markets segmented as well. It really makes sense to segment the transformers market into power and distribution transformers, as I discussed earlier, that different market trends exist for power and distribution transformers. There are different definitions out there in the market. Some definitions follow MVA definitions, and we are looking into voltage from an application point of view, a system voltage application point of view. Whereas anything which is higher than 72 kilovolts would be considered power transformers, and anything below up until 1 kilovolt is considered as medium voltage transformers. If we look at the global market size, the market valued at $16 billion US, which was a 6% decline from 2019 market. Part of it definitely came from the impact of COVID. Overall, if we compare it with the distribution transformers market, this is where we see that DTR market got really impacted because of COVID. That's where we see a higher impact as compared to power transformers market. Overall, the DTR market was valued at $7.3 billion US dollars in 2020, which was nearly a 20% decline from 2019 market. We'll discuss this in detail, that what were the factors contributing towards this. Of course, COVID, as I discussed, is one of the factors. And then there are some other, let's say, factors which are impacting this decline in distribution transformers market. And this is something which is still true in terms of the recovery. Power transformers market is recovering, and it's close to the 2019 levels already. If we do a comparison of different quarters between 2019 and 2021, but for distribution transformers market, it is still not to 2019 levels at this point. Kind of a segmentation in different regions. Looking at the global overview, that's where we have segmented the power and distribution transformers market. And on the right-hand side in the pie chart that you see, this is where we have the total entire transformers market. And it's quite clear that APEC, because of China and India, is basically the 50% of the global market. And once again, after APEC, different regions like North America, US had quite an exceptional growth, both in 2019 and 2020, for not only for transformers, but overall T&D market. To discuss some of the key trends, drivers of the market, and then also looking at the outlook of transformers and overall power grid market. This is where the slowdown that we discussed in distribution transformers market, a big portion actually came from China. A lot of the projects, especially in the rural electrification projects, they got finished towards the end of 2019. Hence, there was naturally a slowdown that occurred in 2020 in distribution grid market, and hence it trickled down to the distribution transformers market as well. However, moving forward, there are expansion plans by major transmission and distribution utilities in China, which will kick in towards the end of 2021, definitely impacting the distribution transformers market. We'll discuss this topic of EV chargers in detail. It is definitely already impacting the transformers market, and there is definitely going to be growth associated with the EV chargers market moving forward. China, as we all know, in terms of the electrification in the transport sector, has the highest percentage, not only in the passenger electric vehicles, but also beyond passenger electric vehicles. We talk about commercial vehicles, electric buses. Towards the end of 2020, the entire electric fleet on a global level, 90% of electric fleet of buses existed in China. So because of that, already massive growth was seen in terms of the grid upgrades that came from EV charging infrastructure. It is something which is supposed to continue moving forward. The public and private charging infrastructure which China plans to install definitely is going to have an impact on overall power grid market, and of course this is supposed to trickle down to the distribution transformers market as well. We'll discuss the renewable angle. Major growth that came in 2020. China and the US were the main contributors. Already wind and solar capacity additions from China, they were in double digits in terms of the gigawatt additions. Since there will be a slowdown naturally, since the country will meet most of its targets, so there will be a slowdown towards the end of 2022 as major projects will already be installed. US, we discussed that, of course, renewable was a big factor. However, beyond renewable, grid modernization is main, let's say, a factor which is going to impact the market of transformers for US moving forward. Under the new administration, the clean energy goals, there's $8 billion which have been allocated for loans, which are dedicated for grid modernization and access, and basically having access to the grid modernization equipment into its power grid. And then finally, a problem with which the power grid of the US has been coping for a long time now, which is the aging grid infrastructure. So that a part of money is also supposed to impact that or address that topic as well. In terms of the growth potential within EV charging for the US, once again, we'll discuss this in detail in the next section. Commercial vehicle or depot charging will be a huge factor for the US because unlike some of the other markets, it's not only the passenger electric vehicles, it's beyond passenger electric vehicles where the growth is expected in the US market. Overall, T&D spend, we'll see a dedicated slide on this as well. US actually surpassed China in terms of the total T&D investments for the first time in the decade, which was a major achievement in terms of the total investment flowing into this sector. For Europe, grid expansion plans actually were delayed once again because of COVID, but moving forward with updated timelines, the grid expansion plans from some of the main TSOs and DSOs, they are supposed to kick in and definitely drive the transformers market. And once again, it will be a combination for Europe in terms of the EV charging and renewables, both impacting the market of transformers moving forward. If we talk about Middle East and Africa, there's definitely movement which is now happening in Middle Eastern region. Some of the mega infrastructure projects which were sort of delayed and pushed back, now with the updated timelines, they're gradually being resumed. So kind of the overall market potential which existed back in 2019 and 20 has been kind of shifted towards 2021 and 2022. We do expect a peak because of that in 2022, primarily in markets like Saudi in the region. Slowly, there is demand that is coming from the renewable sector. We already see some of the demand that is trickling down to the infrastructure like STATCOMs or SVCs, which we did not see in this region in the past, and primarily because of non-existence of renewable in the power grid sector. But now, more and more integration of renewable capacity, we already start seeing this in the market, and definitely this is something which is going to impact the transformers market as well. India will see exact, let's say, percentage of the T&D spend which happened in 2020. But if we talk about the transformers market overall, definitely got impacted both on the power and distribution transformer side, and slowdown did occur because of COVID-19. Power transformers market, as I discussed earlier, for many markets, it is already sort of recovering close to 2019 levels. But for distribution transformers market, it was significantly impacted. We already saw a double-digit decline in terms of the distribution transformers market of India. Even though there were a lot of plans which kicked in before 2020 in terms of grid modernization, reducing the or increasing the efficiency overall in the grid because of the low efficiency of transformers. That has been a problem in India over the past couple of decades, since a lot of distribution companies and central agency is also trying to sort of address. And now there's set goals for many utilities to have the losses limited to a certain factor. And that we already saw this was impacting the transformers market. But all of that got impacted in 2020. And still this is the case that for distribution transformers market is not back to 2019 levels. And we do not expect that to happen even towards the end of 2020. Overall, the country had a very ambitious target of adding roughly 63,000 megavolt amperes in terms of the grid capacity. Looks like in the fiscal year 2020 and 2021, it's very likely that the country will miss its targets. And of course, this will then be pushed back because this is something which cannot be avoided if India is to achieve its renewable targets moving forward. So hence, this is something which gets pushed back in the coming years. But as of now, the country missed its targets roughly by 40% of that 63 GVA of grid capacity, which the country was supposed to add. Moving forward very quickly, since the research that you saw some of the data points on regional and on the global level, the research is conducted on a country level. So it's a very bottom-up methodology, which we typically use to sort of highlight some of the other key markets. This is where we are segmenting the power and distribution transformers market for the US, Brazil, Saudi, UK, India, and China. And once again, what you saw earlier was kind of a combination from bottom-up methodology, from going from the country level towards regional and finally towards the global level. With this, I will move on to a topic which is, you already saw that it had an impact on overall on the T&D sector, also on the transformer sector. It got trickled down towards transformer sector. We saw how power transformers market, primarily because of the fact that overall timelines of the projects, they are flexible, they are long-term in terms of the bigger projects, which then define the market of power transformers, whereas distribution transformers market, they are defined by short-term plans and goals, hence it got impacted more. We'll see that from overall is investment perspective that how many investments were flowing in the T&D sector, and then which regions and countries had the most amount of impact going into 2020 because of COVID. It's important to mention that overall the T&D sector, the amount of investments coming into many countries, there was a decline even in 2019. As you see in the rest of the world market, that's where we have all the markets covered beyond US, Europe, and China. There was a 20% decline in the total T&D investments. And this was basically a result of overall economic slowdown during the year as well. And a lot of the utilities, they were sort of revamping or let's say reanalyzing their plans of grid expansion going into 2020. So hence there was already a decline of 20% in the total T&D investments. A major portion actually came from India once again in 2019, and then further in 2020 we see a 16% further decline in the total T&D investments. And as I discussed earlier, this not only affects transformers but anything which is in and around of T&D area, overall power grid sector. US was the only exception over here, where 2019 saw a positive flow of investments, so 9% increase from 2018, and then even within 2020, 7% positive growth was observed in terms of the T&D investments. For Europe, we already saw that some of the major T&D companies, so TSOs and DSOs, they sort of had to delay their plans in 2019. So hence we see a 4% decline in the T&D investments. Whereas in 2020, an 8% increase in the overall T&D investments was seen, and part of it did come from the renewable sector, since that does impact overall the spend in the T&D industry. China, this 10% decline, something that we discussed earlier, this was because of the completion of many large rural electrification projects, which got completed. So part of it is coming from that let's say angle of completion of the projects. However, moving forward, there are some huge plans to expand the grid capacity in both in transmission and distribution sector. More on the distribution side. Once again, one of the main instigators of that is going to be the EV charging infrastructure. And then further 8% decline was observed in the year 2020 for China. If we sort of segment out the renewable sector, then the picture looks very different. What we saw previously was only in the electrical networks on the T&D sector. However, renewables, looking at them even within the year 2020, renewable remained a success story. If we look at year 2019, there was already a 6% growth in terms of investments on a global level. And even within 2020, 7%, even higher increase in terms of the investments that we saw throughout the year. A major portion actually did come from China and the US. Massive capacity additions in terms of solar and wind occurred. And as we discussed earlier, that in case of China, this is going to slow down towards the end of 2022 because the country will have most of its targets or close to its achieving its targets, both for wind and solar. So naturally a slowdown is expected, but that kind of gets compensated moving forward from some of the markets where we see already huge standards already in place for both wind and solar capacity. Countries in the Far East region would definitely be the ones that one needs to keep an eye on. So this is something which gets sort of nullified, the decline that we expect in China for renewables from some of the other markets moving forward. And if we compare it with the investments which went into the conventional fossil fuel generation, we see that there was a 15% decline in terms of the overall investments in the year 2020. Moving forward, to see that how COVID-19 impacted the transformers market, as we discussed earlier, distribution transformers market definitely got impacted it's still under a lot of pressure because the market is not back to what it was in 2019. Whereas power transformers market is sort of got recovered in the first quarter of 2021, and it's already towards, let's say, those levels which might exceed 2019 market value in the second half of the year. Lead times definitely were impacted for the larger transformers, for power transformers. For some of the companies, it was beyond even 3 months in terms of the lead times increase. However, once again, in 2021, lead times are back to normal because overall the situation got better in all the regions where the production is happening, and then the lead times got improved quite significantly. Capacity utilization, this is where we looked at the capacity utilization of transformers manufacturing facilities around the world. Overall, some regions got impacted more than the others, but on average, a 15 to 20% decline in capacity utilization was observed throughout 2020. Moving forward, markets like US, China, and many of the European markets, especially the Western European countries, this is where, since huge expansion plans already exist in the grid infrastructure, even though we discussed a potential slowdown in the renewables market for China moving forward beyond 2022, but as far as the grid expansion plans are expected, they're supposed to kick in towards the end of 2021, and it is supposed to bring the overall market very close to 2019 level, definitely for power transformers market, and there is some speculation going on for distribution transformers market towards the end of the year. Moving forward, a few insights in terms of the growth drivers. We've already touched on a few items already. EV charging is something which is already impacting overall power grid market. There are definitely different angles from which one needs to analyze this. It's not only looking into the public charging infrastructure. So anything which goes beyond public charging infrastructure investment needs to come in from the private sector. So hence it needs to be analyzed separately from public charging infrastructure. Renewables, we talked about this briefly, that it is something which already impacted transformers market significantly, and this trend is supposed to continue moving forward. So this definitely becomes a growth driver. We'll discuss digitalization overall, not only in the T&D sector, but in the transformer sector, especially, that how both of these are intertwined with each other. EV charging would dictate more digitalization, but digitalization would be necessary to have overall O&M costs reduced for most of the utilities in the world. So it's kind of a cause and effect, circular cause and effect relationship going on between these different growth drivers moving forward. If we look at the e-mobility sector, I think a deep dive into this sector is very crucial. As I discussed earlier, that public and private charging infrastructure is impacting this market differently. And that's why we as a research company are also looking into this from different angles. Public charging infrastructure, where investments are coming in the public domain. A lot of utilities are involved as well in the grid upgradation. However, on the private charging infrastructure, so this would include a charging infrastructure which is generally not accessible to public. So it includes not only the employee parking charging in different companies, and then also it includes the depot charging by the fleet operators of commercial vehicles. That includes the last mile delivery vehicles, and then also electric trucks. So a very different, let's say, set of dynamics that exist in the private charging infrastructure, and both are supposed to impact the transformers market moving forward. Looking into the different sectors from a vehicle point of view, it's very important that we analyze this from not only from passenger EVs, because I think there is a lot of discussion going on around the electrification of passenger EVs and how it is impacting the charging infrastructure. But that is only one side of the picture, because it impacts of course, the residential charging is driven directly by the passenger EVs, but it does not have a direct impact on the transformers market. It does, because part of the residential charging, of course, this is where we have charging infrastructure which goes into single dwelling, multi-dwelling housing infrastructure as well. So it does have an impact, but a rather minimal impact on overall transformers and T&D market. more on the light commercial vehicles. So that's what LCV stands for electric buses, electric trucks, because that's where bulk charging is something which is common. Charging in a depot setting is something which is common. So that's where a kind of a cumulative effect of chargers installed in a single place gets trickled down towards the grid infrastructure. So it's very important to analyze not only the passenger electric vehicles, but also LCVs. We see a huge electrification drive going on in terms of LCVs. A lot of companies around the world have pledged to have a certain amount of electrification in the fleet of light commercial vehicles that they operate. We already see examples from Amazon having a certain number of electric vehicles in their fleet already, and then moving forward, they plan to have a major portion of their fleet already electrified by 2025. It's something which is not directly dictated by the policy set, because the policies typically by different countries are set on the electrification of passenger EVs, on buses as well. But LCVs, that's where I said earlier as well, that sort of investment is coming from the private sector. It's basically based on the goals set by the companies themselves on the electrification of LCVs and electric trucks as well, because that also sort of ties within the fleet operation by different companies. Moving forward, how does this impact the transformers market and overall power grid market? We all know that EV charging hardware is much more than the charger itself. There is make-ready equipment, which is sort of there to support the charging infrastructure. It is becoming more and more evident as we see the increase in charging power. Typically, what we saw earlier in the last decade, that for the residential charging infrastructure, the charging capacities were already towards the lower side. AC charging is something which is common and is going to be the case moving forward as well. But in terms of the public charging infrastructure, that's where we see more and more DC charging and high power DC charging infrastructure, which is getting installed. Trend basically is that some of the mature EV markets where public charging infrastructure was more towards 50 kilowatt charging, typically that is moving towards high power charging infrastructure, which then is dictated by the average battery size. So new models of passenger EVs introduced by the automotive OEMs, which are already in the pipeline as well. This is something which is very evident, that public charging infrastructure will move towards high power charging. And then additionally, for the commercial vehicles, for depot charging, high power charging is something which makes sense. That is for opportunity charging. However, for depot charging, AC high power and DC low power 50 kilowatt chargers typically is something which makes sense. But a combination of high and low power charging would be something which is going to be the case moving forward for fleet operators. But since I discussed earlier that this is where we have a kind of a cumulative effect of several chargers installed in a single place. So upgrades on the back end is something which is definitely required. And as we see, the transformer is one of the major components which then gets affected by the number of chargers installed in a single place. Grid upgrades would be required for some of the charging hubs. This is where the high power charging infrastructure for electric trucks. Right now, there are not a lot of models out there when we look at the heavy vehicles. So that would be vehicles higher than 7 tons. We do not see a lot of models, but there is a lot of movement which is expected, given that there are models coming out in the next coming years, and there are plans to have high power charging infrastructure installed for heavy vehicles in the public domain. So that would also require grid upgrades, sort of a combination of grid and storage that needs to be plugged into this entire ecosystem of high power charging in the public domain. So this is something which is not, let's say, going to happen in the short term, but moving forward in the next 5 years, this is where we see a lot of movement, once again, because of the fact that electrification will then sort of go from the light commercial vehicles towards the heavy duty vehicles, more towards the higher than 7 tons electric trucks. So this is where companies who are operating these fleet of heavy duty vehicles will install EV charging infrastructure for their own fleet. Moving forward, just to give you a glimpse of how passenger electric vehicles and light commercial vehicles, how this market is going moving forward, we see a double-digit growth for both passenger vehicles and light commercial vehicles. In APEC, of course, the reason why you see in the pie charts that China already has a huge electrification in terms of the passenger electric vehicles. And this is something which we see changing moving forward. If you look at the light commercial vehicle segment, this is where US, especially in Americas, is supposed to increase its share significantly moving forward. So hence a lot of electrification, as I discussed earlier, is expected to happen in light commercial vehicle area. And if we look at electric buses and the electric trucks, as you see in the pie chart, everything for buses was sort of concentrated in China. That's why you see APEC at 96% in terms of the active fleet of electric buses. So basically, vehicles on the roads of a country in a particular year. But moving forward, as you see that the share from EMEA and Americas is supposed to increase. Same is true for electric trucks, that commercial vehicle electrification is something which is now not only going to happen in APEC region because of China, but it's moving outside China as well. We see a lot of companies already have pledged to have a certain number of electric trucks even in their fleets moving forward. So we see significant growth in all areas, especially in e-trucks, because there is a small market size that exists right now. So hence you see a significant growth of 43% moving forward during the forecast years. To understand how this then impacts the EV chargers market, as I discussed earlier, it's very crucial to look into chargers market separately for AC, and then within DC low and high power charging. So this is where we have sort of a cutoff of 60 kilowatt or 50 kilowatt, which is something which was very common for DC high power charging. But now the trend is definitely shifting towards high power charging for DC, towards 100, 150 kilowatt. So hence it makes sense to have it segmented. And from the growth patterns, you can see that for the DC low power charging infrastructure, still there is going to be growth. And that is going to come from the markets which are more, let's say, nascent in nature, emerging markets, so to speak, for e-mobility. So that's where still DC low power charging is something which is not going to vanish altogether. But high power charging is where we expect the most amount of growth. So hence, this is a sector which definitely is going to impact the overall T&D market and then also transformers market especially. We cannot ignore AC charging infrastructure because once again, something we touched on briefly, that in cases where we have combination of chargers installed, in the depot setting for light commercial vehicles, the model which has been successful so far is AC 22 kilowatt chargers. But this is where we have oftentimes hundreds of charging points which are typically installed in one place. So hence, having a strong enough grid on the back end which can support this charging infrastructure is something which is very important. So that's why we expect that even AC charging infrastructure is going to have significant effect on to the transformers market. The portion which is the residential charging definitely is something which does not directly impact the T&D market, but still in cases where we have chargers being installed in apartments, there are a lot of countries which have regulations in place that any new building infrastructure is supposed to have grid upgrades for any future installation of AC chargers. So even within residential chargers, there is a segment that affects the transformers market moving forward. To sort of summarize the entire discussion as to how charging infrastructure is impacting the grid and transformers market in particular, smart charging or managed charging is something which is going to be imminent moving forward. Without which huge grid upgrades would be required on the back end. So this is where chargers are sort of able to speak with each other and also with the grid infrastructure as well. So that's something which is definitely going to happen. We already see this in place, even in the policy. An example of that would be there are a lot of drives, there are a lot of incentives going on in European countries. And we see that there is a requirement that in order to get benefits and in order to avail those, let's say, incentives from the government, one needs to procure smart chargers, managed chargers. So basically, this is something which is already sort of weaved into the policy already. Since this is something which is supposed to support the grid infrastructure, so definitely this is something that one needs to take into account. But this also then dictates that there needs to be digitalization on the grid side as well, on the transformer side as well. So both then can sort of go hand in hand moving forward as far as the smart charging is concerned. Public high power charging, something we discussed earlier, that mature EV markets are very quickly moving towards high power charging. And we see that already in terms of the type of chargers introduced by many OEMs out there, where we saw previously chargers with charging capacity below 100 kilowatt. But moving forward, the upcoming products that we see definitely have higher and higher power charging. And in some cases, even in the markets where right now fast charging might not make sense, but there will be future proofing that would be required. Hence, it would be utilities would prefer to have the grid infrastructure strengthened on the back end, even though the charging infrastructure on the front end is not going to be high power as of now. But since this infrastructure is very modular in nature, so one can expect upgrades moving forward. So already sort of a preemptive approach, a proactive approach by the utilities is something that we can see, that even though the charging infrastructure does not demand a lot of upgrades, a lot of capacity additions on the back end, utilities are still proactively increasing the grid capacity to make sure that in future high power charging infrastructure can be installed in place of low power charging. Private depot charging for commercial fleet operators, as we discussed earlier, that the most viable method is going to be a combination of both overnight charging and then also public charging. And for overnight charging, a depot setting where multiple charging points are installed to charge the complete fleet. There are many different, let's say, understanding which dictate that how many charging points would be there for a certain number of electric vehicles by a fleet operator. Some, let's say, studies predict that there is going to be 1:1 between vehicles and charge points. Our understanding is that it is not going to be 1:1 if you look at the combination of the public and overnight charging. It is at the end of the day going to be dictated by the type of fleet. So the fleet operation, if the fleet operation requires multiple charges within a day, so a high power charging infrastructure would be needed. So overnight slow AC charging is something which would not be required. But in many cases, what we see, a combination of both is going to be, let's say, most feasible option, most viable option moving forward for the fleet operators. And this is where the investment is expected to come from the private sector. So this is where maybe a share from the utilities and the private sector will be there to have the grid upgrades. But on the transformer side, primarily the investment is going to come from the companies who are operating the fleets of electric vehicles. Finally, a topic which we did not discuss already, which is vehicle to grid. This is something which has been in discussions for a long time now. V2G, we already see part of the charging infrastructure which is moving towards the V2G operation. Why is it important? Because we all know that it's V2G, we have a bi-directional flow of information of power. So that means that on the grid side, the equipment also needs to support the reverse flow of the power. Right now, the trend is only in the low power charging. It's very much in the pilot phase, so to speak, because the products which we see already in the market, they're being launched on test basis. For example, we see some new products coming from companies like Bosch, even from Volkswagen, that they already have a few charging infrastructure on the DC low power side, which has the capability for V2G, but it's still in the pilot phase. If successful, then moving forward, we can expect this to sort of trickle towards the high power charging infrastructure as well. And that's where having, let's say, on the back end grid infrastructure, which can support or which can, let's say, fit into the entire ecosystem of vehicle to grid, this is something which will become really important. But this is something which we expect to happen not in the immediate future. So something which we can expect somewhere down the lane 5 to 7 years, where we will have a proof of concept on the DC low power charging side that V2G does make sense for high power charging infrastructure as well. Very quickly into the renewable sector, we already saw that within 2020, there was definitely an increase in not only in terms of the investments, but in terms of the installed capacity as well. Massive capacity additions were made in China and in the US. If you see the pie chart on the right hand side, that roughly 50% of the solar additions actually came from China and the US combined, and then more than 50% actually came from China as far as the wind new additions were concerned. Moving forward, we expect this trend to continue, especially on the US side. This is something which will definitely continue and have a direct impact onto the transformers market. US market is still struggling with the lack of transformer manufacturing capacity, local transformer manufacturing capacity. This is something that the industry is still coping with. So hence, a lot of imports of transformers is something that we can expect. The increase in the market size from solar and wind in the US is definitely imminent, but the supply capacity is something which is in question right now for the US market. Moving forward, a lot of countries have their own targets set as far as the wind and solar industry is concerned. Countries in terms of the solar and wind targets, they have a set, let's say, plans. If we look at markets like US, UK, Germany, Brazil, Australia, there are set plans. Of course, these plans got sort of delayed because of COVID-19. Certainly this effect is there, but with updated new timelines, this is something which we can expect to now start impacting the transformers market. We've only highlighted a very few over here, but of course, every country, especially in the Far East region, they have their own targets set. And this is something which we already see happening. We already see a lot of tenders being approved for large solar and wind projects. So we can expect this market to definitely sort of nullify the effect that we discussed earlier, that the China market is supposed to sort of slow down as far as the wind and solar market is concerned. One final topic on digitalization, and then we can move on to the questions. This is where we discussed earlier that topics like EV charging and renewables demand, let's say, moving forward digitalization on the grid side, especially on the transformer side as well. So it's once again, it's kind of that circular effect, cause and effect that we talked about earlier. But beyond EV charging and renewables, sustainable asset fleet is a topic which is big for many utilities, especially for utilities inside the US, which are coping with this topic of aging grid infrastructure. So extension of operational lifetimes is something which is crucial. So we expect the penetration of digitalization moving forward into the transformer industry, more on the distribution transformer side than power transformers, because that's where we see already products out there, and that's where we see the utilization of the digital aspect in the transformers. For EV charging, it definitely makes sense on the distribution transformer side. If vehicle to grid, if V2G becomes a reality for high power charging, as we discussed earlier, this will definitely be something which would be required on the transformer side to have digital assets installed in the grid infrastructure. So with this, I will then conclude the topic. Any questions, please feel free to ask. I'll ask Liam to jump in as well, and then we can moderate the questions, and then we can go through them one by one. Thank you. Hi, Liam, are you with me?
Hi, Saqib. It's Liz here, actually. I think Liam's had a few challenges with his internet, so hopefully he will be joining us soon, but I'll step in here. But firstly, thank you very much for your presentation, and I can see that we've got a few questions coming in on the right-hand side here. And to everybody that's still listening, please do feel free to put your questions in the Q&A tab, and we'll do our best to get to them just shortly. So looking at the first question, Saqib, it says, will the low loss domain refined electrical steels for large power transformers and amorphous steels, I hope I pronounced that right, for small power transformers have an impact on the market, given the growing environmental concern on the power losses?
I think low loss grain is still in very early stages. I've seen a lot of research papers actually from this year on this, and the losses already are very low on the power transformer side, especially when we see the Eco Design Directive taking effect in European countries. So it's already sort of dictating the efficiency on the transformer side. So it's not already a big issue as far as the power transformers are concerned. But moving forward, we can expect this to sort of take effect if further, let's say, regulations are put in place to have further efficiency improvement in power and distribution transformers. It would be first on the distribution transformers, where we expect this to sort of have an impact. As I discussed earlier, this is something which many countries are coping with right now, having low losses in the grid. If we talk about the countries like India, where having a higher efficient grid and low losses in overall grid infrastructure, which actually stems from transformers. A big part of it stems from transformers. So distribution transformers is something we expect this to impact first, not on the power transformer side, because of the reason that already power transformers are very close to that, let's say, that high efficiency expectations which we have for power transformers.
Brilliant. Thank you very much, Saqib. I can see, I think that Liam is actually back online. So I don't know whether Liam's going to jump in here. If not, I'm happy to keep going. Liam, are you there? I'm not so sure. So we've had another, I'll keep going here, Saqib. We've had another question in from Michael, which is, are there any efficiency regulations established or planned for EV charging systems?
For EV charging systems, not particularly on the transformers. Efficiency regulations on the transformers are actually the ones which have already been in place. So it's something which is going to come from the utility side. So EV charging is not going to dictate the efficiency onto the transformers. So this is sort of a kind of something which is disconnected. On chargers itself, yes, definitely there are requirements to have certain level of efficiency. This is an industry which is very closely driven by what we saw in the solar industry. In the solar inverter industry, we saw how not only the cost went down very quickly, how the efficiency requirements were put in place for the solar inverter industry. So this is what is directly driving the EV chargers industry. A lot of the regulations put in place, they were already very, let's say, well-defined for EV charging infrastructure, especially for the DC high power charging, because this is where we have higher, let's say, higher losses possible for a DC high power charging. So that's where we already see a lot of regulations in place, but its effect onto the transformers is something which does not exist as of now. So EV charger industry would not dictate that what would be the efficiency on the back-end system onto the transformers. It's what already in place from utilities, from regulatory authorities onto the transformers market across the industry. So EV charger industry especially is not going to, let's say, dictate the efficiency requirements on the transformer side.
Okay, fantastic. Thank you very much. We have another question in from Hassan, which is, when do you expect depot charging to really pick up with the 1 MW systems? And you mentioned which will lead to the demand of transformers in these depots.
I would say in a timeline of 2 to 3 years. Because right now, the fleet operators that we talked about, there are few companies out there in the US, in Western European countries, where we have a lot of electrification going on. Systems as high as 1 megawatt, we already see very few pilot projects. So we expect this something to come in from 2 to 3 years from now, primarily because the type of infrastructure is very in its infancy right now. The type of chargers that we're talking about, 1 megawatt, higher than 350 kilowatt, very few products are out there. So hence there is not a lot of price pressure that exists on this type of charger. But as we moving forward, we have more and more companies entering this arena. By the way, this is DC high power charging is an arena where a lot of competition is going to exist moving forward. Right now, we see a few number of players because of the fact that It's a specialized piece of equipment. Not everybody is producing DC chargers, so less competition exists right now. But moving forward, we expect this to change, which will put more price pressure on DC high power charging as well. And then a proof of concept will be there that overnight depot charging, slow power DC charging is something which is effective, is something which is possible. So moving forward, DC high power charging will have a proof of concept then based on low power charging. So we expect from 2 to 3 years. Within that, you need to also look into some key markets. US is definitely one. Germany would be another one, where we already see these pilot projects in place. So we expect these markets where these ultra high power charging, so to speak, will take effect within a timeline of 2 to 3 years.
Okay. Brilliant. Thank you very much. So we have one final question, and I think then will be perfect timing. So the final question is, what do you predict will be the impact of solid state transformers on the market?
So we have been tracking this for quite a long time now. Solid state transformers, of course, is from a, let's say, concept point of view, we already saw some niche applications of SSDs already in place. But this is something which has not yet entered on a large scale as of now, primarily because of the price parity, the difference that still exists, and also the fact that the conventional transformers are proving to be enough for any bi-directional, let's say, flow overall moving forward. So it's the combination of conventional transformers with EV charging is something which is working as of now, because there was a lot of discussion that how solid state transformers will they will go hand in hand with EV charging infrastructure. You have a lot of power electronics in the grid overall, so it makes the entire system efficient. You can have a lot of devices speak to each other as well. So hence SSD working in the ecosystem of EV charging makes a lot of sense. We have not seen that in place as of now. However, there is an area, if that picks up, which I talked about in the presentation as well, which is V2G. If this is an area which gets this proof of concept from these low power devices, by the way, these are low power DC, typically 22 kilowatt chargers, not the high power chargers where we see V2G concept in place. Right now, the products are geared towards the residential end users, so residential charging infrastructure. So that's where there's discussion of V2G, V2H applications as well. But if this then moves towards the high power charging, then a combination of high power charging with V2G capability and having a solid state transformer in place is something which might make sense. But as of now, we have not seen that in place, apart from a few pilot projects around the world.
Sure. Okay. Well, thank you so much, Saqib. And thank you, firstly, thanks to everyone for tuning in, and also for Saqib for such a great presentation, and also for answering all of your questions. I think we've just about reached our limit time-wise, so unfortunately we can't get to any more. But as I said, just want to thank everybody that's tuned in for your engagement, and we do hope it's been insightful for you all. The full webinar recording will be made available on the Quimey Knowledge Hub on our website later this week, where you can also find all of our other webinars from the past year, as well as our newsletter and other exclusive kind of market reports and articles. The full white paper itself from this session will be released next week, so look out for this in your inbox, and you'll also be able to download it from the Quimey website. And finally, we're looking forward to seeing all of you at the next 2 Transformer webinars taking place today. Firstly, with Block Transformorten, I hope I pronounced that correctly, starting at 1:30 Central European Time, and finally for a panel with Power Technology Research at 3:30 Central European Time. So thanks again, and see you very soon.
Thank you very much. Bye-bye.
Thank you.